Okay, let's unpack this. Imagine trying to, you know, generate clean energy efficiently when the sun isn't always out, or when your panels are buried under snow. That's a real challenge, especially somewhere like Minnesota, right? Famous for its tough weather. But what if I told you they're turning raindrops,
Yeah.
literally raindrops, into power? Today, we're digging into rain-powered solar.
It really is fascinating. Minnesota's energy scene is having this sort of quiet revolution. We're talking about mixing traditional solar panels with these things called triboelectric nano generators, GANs for short. And it's not just like a backup. It's a proper dual energy approach. It tackles those exact problems: low sun, rain, even snow. It's a really practical step toward getting power, continuously, being more resilient.
A dual energy approach, huh? That really does sound like a breakthrough. So for you listening, our mission today is simple. We're going through the sources, pulling out the key bits about this hybrid system, how it works, what it's actually doing on the ground, all broken down for you. Right, this is where it gets really interesting for me. It almost sounds like science fiction. How can a simple raindrop actually create electricity? And how does that even fit with a solar panel?
It's pure science, actually. Remember rubbing a balloon on your hair? That static cling? Well, it's the same idea. It's called contact electrification. So when a raindrop hits a special surface, they often use something called FEP, fluorinated ethylene propylene. That tiny bit of friction creates electrostatic charges. The drop gets one charge, the surface gets the opposite. And that difference, that little push, that's what generates a current, turns motion into power. And the tech's improved a lot. They're now hitting peaks of 200 watts per square meter in some designs.
Well, 200 watts,
Mm.
that's nearly 5 times higher than earlier versions, isn't it?
Exactly. It makes them a genuinely useful power source now, not just a lab curiosity.
Okay, so that's a huge jump. But how do you actually mesh these tenges with solar panels? Is it just stuck on top, or is it smarter than that?
Oh, it's definitely smarter. There's real synergy. Often the 10 layers are transparent films, sometimes made with carbon dots. And here's the clever part. They do two jobs. First, they can actually reduce how much sunlight reflects off the solar cell surface, so they can bump up the solar efficiency itself, maybe from, say, 13.6% to 14.6%. Not huge, but it helps.
Okay, so it helps the solar panel work better.
Right, and at the same time, it's capturing that raindrop energy. They've measured up to like 13.9 microwatts from just one raindrop hitting it. Now, one drop is tiny, obviously, but think about a real downpour. Thousands, millions of drops. It all adds up, giving you power even when the sun isn't strong. That's massive for Minnesota. Spring rains, snowmelt, times when solar struggles.
So Minnesota's really leaning into its weather challenges, turning rain and snow into an asset, basically. What's their specific story here?
They're definitely pioneers. The University of Minnesota, they started a big project back in 2017, got funding from the Environment and Natural Resources Trust Fund, specifically to develop TNGs for powering environmental sensors out in the field. And they've had some pretty impressive results, like 500 watts per square meter power density just for keeping remote sensors running. Then a study in 2023 showed these hybrid panels actually generating more power during rain than the solar cells alone. And you hear from people in Minneapolis, right? Their solar panels sometimes produce almost nothing from December to February because of snow cover. So you see why this hybrid idea is so appealing.
Yeah, that makes a huge difference, especially in winter. So, okay, beyond just making power, what are the practical impacts? Like, what real problems does this solve?
Well, the big picture is it helps fight that huge efficiency drop solar panels see in Minnesota winters, sometimes 30–50% less power. KNGs help keep some power flowing. Take Duluth. They had a solar tank setup that kept running at over 90% efficiency during April showers, with powering e-bikes and sensors.
90% during rain.
Yeah. And think about monitoring, say, the Mississippi River Basin. These things can power sensors right through heavy rain, preventing data gaps, giving real-time flood warnings. Or agriculture. There was a pilot in Rochester, 2024, hybrid systems powered automated irrigation, cut waterways by 45%, kept sensors running 95% of the time, powered by the rain itself.
That's seriously impressive stuff. Okay, but it can't all be smooth sailing. This raises an important question. What are the hurdles? What needs to happen next?
Yeah, good question. A major challenge, especially for Minnesota, is just making the materials durable enough. Think about the humidity swings, the freeze-thaw cycles. These 10 thick materials need to last for decades out there. That's tough. And then there's policy, getting support. There's talk of a 2025 Renewable Integration Act to maybe subsidize research, encourage installations. Plus, partnerships with manufacturers like 3M are crucial to actually scale this up and get it into the real world.
So we've really unpacked how Minnesota is pushing the boundaries here, creating a hybrid energy future. using both sun and rain for more reliable power. It's pretty amazing innovation driven by necessity.
Absolutely. And what's fascinating is how Minnesota's approach, tackling its specific climate issues
Yeah.
could actually be a model for other cold places around the world. It really makes you think, what other energy sources are we just sort of overlooking right now, hiding in plain sight?
What stands out to you about Minnesota's rain-powered solar?